Ready, Paul? What is being tested? So in this case, the 100 people with eczema. The treatment is what do you actually give the people? Well, either the old medicine, old drug, or new drug. Either old drug or new drug. The levels are always the same as the treatment unless we have like 10 grams, 5 grams, 3 grams. Levels are like how much of each treatment. Well, here we're just giving the same amount. It doesn't tell us that there are any levels. So the levels in this case are still old drug and new drug. Because it doesn't tell me there's any like 10 milligrams versus 3 milligrams versus 5 milligrams. And finally, the factors. This is like at the highest level, what are we really doing here? We're giving people different kinds of medicine, or if you want to say like lotion, right? Or you could have said like eczema medicine. Like highest level, what's happening here? We're giving people 2 treatments or 2 different levels of eczema medicine. We're giving them the old drug and the new drug. Okay, I think a lot of people got B, that's fine. The only thing on B, guys, and I think I did not stress this before, so I didn't take off for it, but we do need to do this. When you're designing an experiment, so you want to say, like, I'm going to randomize, blah, 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 then at the end you need to say, I want to compare the 2 groups. So the, like, last step is compare the results between the groups. Please make sure you include that on the exam. If there's a free response question that's like design an experiment, the like last step is let's compare the results between the groups. That's all. I mean, that's like. So I think I didn't specify that before, but like you definitely want to compare. That's the whole point of doing the experiment, is you're comparing. All right. Now on C, we did have some challenges. C says. Giselle, is there something you couldn't read? I saw you squinted. Design an experiment using matched pairs. I think people may have forgotten what matched pairs were and then didn't look it up. Does anybody remember what matched pairs are? Anybody remember? I think only a few people got it. Eddie Paul? Yeah, so for matched pairs, here's what you want to do. You want to create pairs, so like person A, B, C, D, E, F, G, H, blah, blah. Pairs of people who are identical. So same gender, same age, ideally same ethnicity, same income level, same education, same everything, and then give one of them old and one of them new. Because you want to compare and get rid of all the confounding variables, because they're exactly the same, except for one got the old medicine, one got the new medicine. So matched pairs is you create a pair of individuals who are exactly the same, or as similar as possible. Give one the old medicine, one the new medicine. You can assign it by like flipping a coin. You can assign it by give these people like numbers, however you want to do it. Great. All right. Okay, so that's all for the review. I want to go over a couple problems that a lot of people missed that are on this kind of topics that we've been talking about recently on the probability stuff. So a lot of people missed question 2. I may have... Did a lot of people put A on question 2 that I marked wrong? I think a lot of people on question 2 put A. Question 2 says, and please note this, guys, because this is common mistake. It's going to come up on the test on a Friday, on number 2. It says, what is the probability that at most 2 drivers are wearing seatbelts? So the probability that X is less than or equal to 2. This is equal to the probability that X equals 2 plus the probability that x equals 1 plus the probability that x equals 0. A lot of people picked answer choice A, which is the probability that x equals 2. But you need to add in the probability that x equals 1 and the probability that x equals 0. Because it's saying at most 2, which means they could be wearing 1 or 0. Really? C. Did I?
Yes.
Did I mark a C wrong? I apologize. C is the correct answer. If I marked that wrong, let me know. I will change that back. If I marked A right, that is the wrong answer. Then that is like a mistake on my part. Because I have C written right here. I don't know how I did that. That's totally my fault. But this is how you want to attack the problem. So the people who picked A, you only said that the probability of x equaling 2. You need to add up x equal 1 and x equals 0. So if I made a mistake, just send me an email tonight and we will add 5 points onto your grade. Okay, so this is number 2. Oh boy. Okay, the free response. Ay, ay, ay. Ay, ay, ay. A lot of mistakes here.
I did well.
What is the probability that Sam's first upgrade will occur after the third flight? So I want the probability that x is greater than 3. Because I want to happen after the third flight. Now, some people mistakenly thought this was binomial. This is geometric. Because I'm asking, when does upgrade 1 happen? When does the first upgrade happen? That means I'm going to keep going till I get the first upgrade. This was geometric in part A. This is geometric in part A. So you want the probability that x is bigger than 3, which means this is saying what is the probability that x equals 4, 5, 6, 7, 8, 9, 10, 11, 12, blah, 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 blah. It's much easier to think about it as this. 1 minus the probability x is less than 3. This is an easier problem to solve. This is a much easier problem to solve. A lot of people wrote this and then they calculated this and they forgot to do 1 minus. They forgot to do 1 minus. So it should have been 1 minus probability x is less than 3. Remember, this is just a geometric probability. You all know how to do that. That is the one that does not have the combination. That is just the regular old p to the first power times 1 minus p to the k minus 1, where this is k. Now, on letter B, what is the probability Sam will be upgraded exactly 2 times? This is binomial. Because it's exactly 2 times in 20 flights. I'm telling you the fixed number of trials. So the probability that x equals 2, which is equal to, well, there's 20 flights and I want 2 of them. The probability of getting upgraded is 0.1 to the k power times 1 minus 0.1 raised to the 18 power. This is what you want to do on your calculator. Khadija.
So geometric and binomial are going to be on the question, right?
Yeah. That is the topic of the quiz, yeah. Yeah. That is the topic, yeah. And letter C. Sam will fly 104 flights this year. Would you be surprised if he received more than 20 upgrades? Well, how many upgrades do we expect him to receive? Well, we have expected value for binomial is n times p. We have that on the formula sheet. Expected value for binomial is n times p. N is 104 times p is 0.1, which is equal to 10.4. So we expect him to have 10 upgrades. If he gets 20, that's double what we think. That is very rare. I don't expect him to have double as much as the expected. If it said, would he have 11 upgrades? That's not that unexpected. 11's really close to this. But 20 is double this? That's not possible. I mean, it's possible, highly unlikely. Highly, highly unlikely. Questions? Right.
I have the correct equation, but I didn't write down the answer.
Okay, let's talk about second one. That is a fair question. Okay, and the last thing I want to do is one of the problems on the homework that's due tomorrow. So I want to do this problem number 1 right here. This is on the homework due tomorrow. Norma and Brian will give you a copy in a little bit. Actually, let's give it to you right now.
No, 'cause this is one. But then wouldn't there be something wrong? Or wouldn't there be-
No, pero está bien.
This way.
No sé, pues dile
I recommend
tú.
watching the YouTube
Dile you
videos,
give the same
problem,
points like the...
or talk to
Yeah.
your classmates.
No, no se agüite, mija.
Hey, dígale a este también, mami.
All right. And this video.
Oh, okay.